Hey everyone, welcome to another Weekend Projects Hangout on Air powered by Radio Shack. I'm your host, Nick Raymond, sort of a wrap-up for this season's Hangouts. But today we have an awesome lineup. Starting on, I think, my left, we've got David Scheltema, makes technical editor, also the Make Books editor. So hi, David, how's it going?
Hey, pretty well.
We're also joined by Nick Normal, just all-around awesome guy, librarian, Maker Faire guru, et cetera, et cetera. So hey, Nick, how's it going?
Hey, Nick. Thanks for having me.
Always. And then special guest today is Jay Schertle, Maker Block, CNC guru, blogger, 3D printer. Hey, Jay, how's it going?
Good. Hi. Thank you for having me.
Yeah, thanks, guys. So today we'll be talking about the Beatband sleeve project. It's gone through a couple iterations, multiple hands. We'll probably just toss it off to Nick Normal as soon as we start to sort of get an overview of the project. But David had a part in designing a circuit. Jay helped make it a kind of like an armband project. We haven't checked out the project page yet. But Nick, I don't know. Can you tell us about how it started and what was sort of the idea for this project in general?
Sure. So the whole project basically revolves around the Mintduino. So sort of classic breadboard Arduino compatible project for beginners. Takes about 30 to 45 minutes to put together, following the simple how-tos online, and then from there we tossed it to Sophie Uditskaya, who's a Brooklyn-based maker, and her project, her version of the Beatband, or the Heartbeat project, will be going live later this year. But beforehand, we kicked it to Jay Schertle, and he sort of remapped it onto an armband wearable project. That was then redesigned by David Scheltema onto Perfboard, and then eventually all kind of packaged up together into the Beatband sleeve project as we know it.
Awesome. Cool. So David, what was your experience kind of taking on this project and then having to basically take like, if you're not familiar with the Mintduino, is like the Arduino comes in a mint tin. Usually, primarily in the past, we at least had instructions how to breadboard it. So you created actually a whole Make projects, David, on how to perfboard this and how to basically make the circuit something solid that you could actually then port over into this project. What was that like?
That was an experience, and it went through several iterations because most circuit designs have the IC or the AT Mega in this case central to the PCB. So I initially started out and thought, a design like this where you've got the IC socket and plug it in. Yeah. There were a variety of reasons that didn't work out. The most important for me was I didn't want this project to be a one-off in the sense that when you built it, you solder everything, and I wanted you to still have access to all the pins on the Arduino. And so the limitation of the proto board was, it's laid out in a specific way that's unlike the breadboard. So what I ended up doing is a pretty non-traditional, if you're an engineer, layout where the IC is off-center, but it allows access to all the pins on the chip. And also as a benefit, you can fit the battery in the tin, and that's really important in Jay's project because, well, you want the tin to contain most everything.
And so as far as like the layout went, was it hard to basically map? Because if you look at a data sheet, right, so the pins on the data sheet are not necessarily the pins that we're familiar with if we use the Arduino. So like pin 13 on an Arduino board doesn't exactly map to pin 13 on the AT Mega chip. Was there complications in trying to, kind of work backwards or reverse engineer the schematic?
There was definitely a lot of double checking on my part. Okay. And so, I didn't study to be an engineer, and so, this is a layout that anyone can really do, but you just have to double check and really keep things straight. So, I think in the project you can see that I printed out the actual pinout of the IC, and then I drew a little heart next to where I was going to attach it, and it's just like that worked for me. And I think that when you're tackling these things, you got to find what works for you, and that's your best way to go.
Yeah, and I was actually kind of curious. How did you find? In the project, at least, you cut out a piece of paper and you put it on top of the chip, sort of like as a reference, and that came from like your Maker's Notebook, or?
Yeah. So that's right. So it came from the Maker's Notebook. We have a sticker in the Maker's Notebook that actually has the pinouts for the AT Mega. What is it? 328.
328P.
Yeah, 328p. Oh yeah, I gotta remember that. Thanks, guys. But yeah, so I stuck that on, and that was helpful. And then I printed out. Mark DeVink originally did the Minduino, and so back to the lineage, we're taking his baby and moving it along through early childhood, I guess. So yeah, it just I printed that out, and it helped a lot.
And so this is something that people can now go online to make projects, check out how you put your schematic together, see basically the steps, how you place all the components, and emulate that for either this project or future projects. That's kind of the idea.
Sure, and the advice that I have, if you want to have this be open to all sorts of iterations, is to add mail headers to to the IC, and then you can jumper within the tin still and make all the connections you want. Because I'm all for multiple permutations of projects. You don't want to lock anything in. But
totally. Well, that's a good segue. So, Jay, how did you kind of get introduced to this project, and what level of kind of completeness or uncompleteness did you kind of pick up?
So I had used Arduino's projects before, but I had never tried to put together a circuit board from scratch. Certainly never tried anything with a breadboard before. And I was basically offered a chance to take some parts, and then my instructions were, hey, go pick up an armband, a Arduino, and a pulse sensor, and make those parts do things. And I was pointed at Sophie's tutorial, which was very, very helpful, but I'd never actually done anything like this before. So much like David, I don't have an engineering background. I was a philosophy major. Which really prepared me for
and that makes two of us.
Which really prepared me for this project. So it was my first step was assembling the Arduino, and once I'd had that, attaching in some LEDs, seeing how that worked. It actually taught me a whole lot about how these projects worked, because once I built the Arduino, I just started yanking parts out to see what made the light stop blinking.
Trial by error, yeah.
Right. So I figured, hey, I've got an extra one of these here. If I blow it up, I'll just assemble the second one.
Yeah, totally.
So once I'd done that, I ended up putting this together. David's setup is far more elegant than what I'd put together, because the setup in mine is pretty close to what the original. Hold it up there.
There you go. Yeah.
Pretty close to the original Arduino layout. Now the 9-volt still does fit inside, but the difference is the one that I had was kind of a one-off. You program the chip, you drop it in, you solder it all in place, and then it's only going to blink these LEDs with this pulse sensor, and that's all it's ever going to do.
Okay.
So,
you also cut your perf board so that it sort of provided the space and room for the 9-volt to fit inside there. I just think that's a really fundamental solution to a problem, and just feel free to cut things and modify things and make them fit the way you need them to fit. So it was pretty interesting to see.
Yeah, I had to do a lot of things that I had zero experience with. One of them was the way in which I punched holes in the tin.
Okay.
I used tin snips over here to take a piece out so I could run the wire through, and then covered it with electrical tape so it wouldn't chafe, and then destroy both the armband and the wires.
You also recycled the instruction sheet inside the tin back into the project, which again was a great upcycling.
You don't want the board to short out on the tin. That's one of the biggest issues, right? Is having your electronics. Yeah.
So I used for the Arduino itself, it comes with just a little insert that says, "Hi, I'm a Arduino." I dropped that in the bottom because this is just bare circuit stuff. So now it doesn't short on the bottom, and I took a loyalty card from some local business, and I just put that on top of it, along with a piece of cardboard from the actual package for, I think, the perf board. And that just just insulates the LEDs to keep them from shorting against the inside of the tin. So there it goes.
And so essentially, if for people who aren't familiar, how does the circuit work? There's this pulse sensor which you can get at Makershed. Order that.
Yes.
And what does that do?
Okay, so the pulse sensor, there's a little light on there, and it's set up so that let's see if you can see it, so that it uses the light to detect, I think, the variance of the blood vessels or something. I don't know how that stuff works, but there's a sketch that's ready to go that you could load into your Arduino and have it detect when those pulses hit. From there, it was a matter of just connecting just a couple of lines. And for this, I really just basically cribbed what Sophie had done, and then sent all of that data to the pin 13 on the, if it was an Arduino, it'd be pin 13.
The light pin.
Exactly.
Okay.
And so I sent all the data there, which I wired up to those 3 LEDs, which I'm not really supposed to, but I did.
Awesome. And so when you are exercising or your heartbeat is increasing, the LEDs visually show sort of the pulse that's getting picked up by the sensor. So
yes, exactly.
Cool. I mean, a pretty basic application as once you like make your own microcontroller. You know, I mean, that seems like that's the beast of the project and figuring out the enclosure.
Yeah, and once I tried this and made this work, it was really kind of an eye-opener for me, like, oh, well, I use the Arduino itself plus a set of stock instructions for gathering input and then something else for creating an output, and I can just kind of wire these things together, and it kind of works.
And I mean, how long did that take to figure out? I mean, was that not a week, a couple days, like seriously a weekend, or?
I only had a couple of days. They said,
it was
here's a box of stuff. You have a couple of days, so make it happen. And I didn't blow anything up, and it kind of worked. It was really more a function of, well, we got to have something soon, so can you do this? Than talking about my abilities to make stuff work. So a couple of days.
Yeah, nothing like a deadline to make you productive, right?
Absolutely, yes.
Yeah, so Jay's exactly right about what the sensor itself is doing. It's actually an IR LED and a photodiode, and what you're doing is you're shooting light at your capillaries, and so when your blood is pumping through your capillaries will slightly expand, like we're talking on a micron level, and so that's going to pick it up. The sensor is going to bounce and pick it up, just like your sort of submarine ping sensor or your distance sensor. And so he's exactly right that this is just deploying an Arduino to do something, and to do something that's commonly done in robotics. And so it's pretty cool that the sensor allows you to do that, but that shows the power of sensors, right?
Yeah. And so, David, is it an analog sensor? It just takes analog data in, and it just basically maps it to the pin 13 or the LEDs?
Yeah, because the power of the Arduino is that in your sketch you can interpret voltages or amperages to give you give you something to interpret, and then you can make the world around you make sense. And so I think that's the core of what physical computing is. It's making sense out of something that's sort of in a different language, but can tell you and give you insights about your world.
Making sense and making it accessible. That's the really amazing thing, both about the Arduino, the Arduino, the pulse sensor, like Jay said, like these kind of two disparate products, and like sticking them together and then being able to extrapolate pretty important data that would otherwise be inaccessible. So.
And it's a cool form factor. I mean, you can literally put it on your sleeve in this application with the Mint tin. It seems like a pretty basic, just like a fabric sleeve. Other applications, I guess, like when you're playing video games.
It's a sort of generic sports sleeve. The thing you put like your MP3 player in, like while you go on a run or something like that.
Even that is pretty off the shelf. It's not like a specific thing.
And then just modified and sort of slightly tuned to the project.
So Jay, is this sort of like how you approach other projects? We could maybe segue a little bit into some of the other projects you're working on. Maybe talk about that, but just in general, taking a problem, seeing what you have on hand, and then kind of applying no nonsense, just get it done?
Sometimes, for sure. I participated in the robot hacks thing through Make a few weeks ago, and so definitely for that. Although, honestly, when I have a problem, like a physical problem that needs to be solved these days, 95% of the time, I've got a 3D printer. I just make a solution and then call it done. Rather than like, I don't have to necessarily MacGyver anything because I can just make a new part. But did you want me to talk about my robot hacks thing, or?
Yeah, if you want to talk about the robot hacks, and then also, I'm super interested in the Arduino side, but also the 3D printing and then making CNC machines with CNC machines. I'm always
Sure.
very fascinated by that, so I know.
So what I have here is part of my robot hacks was the goal was just to take a box of stuff, again, from Make, and I took those and I really focused on the 3D design aspect, and I designed this kind of super lightweight, very minimalistic, actual no-fooling 3-axis CNC. And so it can
Very
move back and forth using a rack and pinion system, forward and then back, and then there's a very, very tiny Z-axis.
Can you hold it up just a little bit more?
Oh, how's that? Does that help?
Right.
There's a picture on my blog, plotterbot.com, and it shows it basically sitting on a paperback novel. It's smaller than a paperback novel, and I opted to go with an actual Z-axis that lifts up at whatever increment you specify, versus just a pen lift like an eggbot would have, because that's just up or down, and it's also moving on an angular, just basically strapped to the servo arm.
Okay,
versus,
so it kind of tilts.
Yeah, so it would tilt during that movement, versus if you were working with, let's say, a paintbrush, or somebody actually talked about using this exact system with a syringe to do something with viruses. Hopefully good things, but but it's able to lift directly up and push directly down. And so using that, it's actually a 3-axis CNC, and it's something I've been working on for the last couple of weeks. It's just over a month old right now, and I've been through a bunch of versions. So, yeah.
And what are you using to power that? Is that similar to can an Arduino do that, or I saw there's some servo?
So what I used is, instead of, for most CNC machines, you have these big, gigantic servos that have a lot of power and are able to move really precisely. What I had was a box with servos in it, so I used the servos. There was a project I'd seen a couple years back called the Piccolo by IATM Studios, and it used servos which only move 180 degrees, and these big gears in a rack system to do that. They haven't published much stuff on their website yet. I hear they're going to, but using that as inspiration, that's what I used here. And actually, I started with one of the Arduinos that I got from the Armband project, and I got it working off of there. And once I had, I then most recently wired up this. This is the X, Y, and Z stuff for the CNC, but I wired it up to an Adafruit trinket.
Okay, cool.
That I'd gotten recently. So that's that little CNC project.
Yeah, it's awesome. I was just kind of surfing throughout their Thingiverse, and I saw this little, okay, I think at first it might have been a 2-axis, or maybe it was all 3 axes on Thingiverse, and I was like, oh, that's super cool. I had just gotten, a 3D printer, and I'm like, what can you make with that? And to see that and, right away realize, oh, that's a little CNC machine. It's using a pen or a paintbrush or what have you, but it's really cool to see,
well, if you saw
machines building machines, that kind of like the iteration process. So.
Yeah, 2 weeks ago it was a 2-axis CNC, and about a week ago I added the full Z-axis. So in the next couple of weeks I'm hoping to. Well, one of the problems is there's only 8 plastic parts, and so when I have to redesign one part, it kind of affects how everything else fits together.
Right.
So I just decided to change some of the parts, which means I got to change everything. So, but stay tuned. There's more.
Keep on iterating.
Yeah, that's a perfect example of the Beatband sleeve, right? You start with one idea, and it might not be ready at the time that you have to launch a project, so you sort of do an iteration below that, or you simplify the design, and then it gets handed off, or you have to do kind of like split versions where you add a second axis or a third axis, and then you completely redesign. That's kind of like making, inventing, tinkering. So it's a
Yeah,
cool
be
process.
sure to
I
look
really
for
love
Sophie's project because it's a ring wearable actually. So it's really neat. You
Whoa.
need to like hold a lipo or hold the 9-volt in your hand, or maybe like slip it into a glove or something like that. But
Like
it's a
scanning
pretty
down.
neat, like finger display of your heartbeat. So if you want to go on the dance floor and like have your heartbeat pulse in, it's pretty cool. So look for that soon.
But I think at the core of this stuff is just an approach with critical thinking, right? So Jay and I both are not trained engineers, but we have a goal that we want to accomplish, and there are tools out there, and with a little reading we can get to them. And I think that his CNC projects are a real testament to just you don't necessarily need formal training, and I think makers everywhere really show this, but that if you approach a problem and you're diligent with it, you can get a solution at this level. And I think that's really awesome. It was really a fun project to work on because I could see, from it wasn't formal engineering, and neither was my stuff. But we got a product we got a project that was pretty cool in the end. And I think that's fun. We both learned a lot. So and that's sort of the key at the end of the day, right?
Yeah, and that's pretty much what the weekend series, the weekend project series powered by Radio Shack is all about, which is beginner friendly. So if you're looking for 30-minute builds, 2-day builds, musical projects, you can do everything from circuit bending, breadboard projects, basic LED projects. It goes on and on. So there's now 55 projects to choose from, which is a project a weekend for a year if you really wanted to get into it. So it's a pretty in-depth series, yeah, and really covers all the bases. So very beginner friendly, and so if anybody out there is looking for something to get started with, check out magazine.com/weekend projects.
Cool. Well, guys, thank you so much for hanging out with us today, and Jay and David for the work on the project, and Normal over in the East Coast for hanging out and chiming in today. So, guys, have a great weekend. Remember, following along at home, check out the projects like Nick suggested. You can pick up most of the parts at Radio Shack, and let us know what you guys are building. So, thanks, everybody.
Happy holidays, everybody.
Thanks.
Thanks for having me.
Happy New Year.
Ciao.